Hey class, this is the first video for quantitative reasoning co-requisite. You should have everything for the regular quantitative reasoning already set up in Canvas. This course is designed to be a support course, kind of fill in the gaps of some of those areas in math that you may have forgotten about or just need to know to be successful in quantitative reasoning. The idea of this course is not to be an extra burden, but more of a support. You won't see as complex of homework. There are some quizzes, but they're not going to be anything to the level of the college level course because it's not designed to add extra stress to your life. It's there to take that stress away. So we're going to begin today talking about fractions. Just some basic review of fractions. You will use this in your homework, and then eventually we'll have a quiz over it. So this is the first video, fractions. Whenever we start talking about fractions, we first want to kind of think of, or at least I like to think, no, that's not what I want. Come on. I like to think of a circle. And specifically because I know you can't see me, but I'm a bigger dude. I like food, and I like thinking of pie. Okay? Not the Greek letter, although that one's fun too, but just some pie. So let's... Now if I cut this pie in half, and then I cut it in half again, now we're looking at... This is my piece of the pie. Okay? My mother-in-law, great cook, had us over once for chicken pot pie. And when she makes chicken pot pie, she makes it like the entire size of the pie. Okay, so this is the portion that I took home, and this is the portion that my wife got to keep. So what I've drawn in here now is 3/4 of this pie. Okay, I had 1/2, and then I added a 1/4. Note, I had 1/2, and I added 1/4. Okay, so when you see fractions, the reason that most people hate fractions is because it doesn't seem intuitive what we need to do here. And what we need to do here is not just add straight across, because what we would really like to do is take 1 plus 1, and that's 2, and 2 plus 4, and that's 6. But that's not what we do. We can't do that, much to our dismay, right? So what we do instead is we're going to take this 1/2 and add the 4th. In order to do that, when we're adding and subtracting fractions, we need a common denominator. A common denominator, we need the same number on the bottom for both fractions. And the way that we do this is we look at the 1/2. Well, the 1/2 over here was 2 of these 4ths. So if I rewrite this 1/2 as 2/4, and then I add 1/4. Now we can start doing some math with this. When we're adding and subtracting fractions, we're going to keep that bottom number the same. Okay. Once we get them the same, we need to keep them the same. So, and that's just going to carry over. Okay. Up top, we take 2 plus 1, and we get 3. So 1/2 plus 1/4 equals 3/4. That might seem a little simplistic to you. So we're gonna go ahead and we're gonna take one step further. Okay. Let's look at 5/7 plus 2/3. Okay, this one may not seem as intuitive as the 1/2 and 1/4. So this time, what we're going to do instead, oh, that's too far. Okay, we'll just leave it right there. We need to find a number that both 7 and 3 can multiply up to. Okay, to do that, what I'm going to do is I'm going to just list 7, 14, 21, 28, 35. And these are some multiples of 7. Okay, and then over here, I need to go 3, 6, 9, 12, 15. I still don't have anything. I'm going to keep going. 18, 21. Hey, look at that. We get to a number that appears in both lists. Okay, we get to that number where 7 and 3 both multiply up to, that's not what I want to do. They both multiply up to 21. So we're going to need to multiply 7 by something to get to 21. Well, we can see what we multiplied it by. 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. So we have 21. Okay, and whatever I do to the bottom here, I have to do to the top. We didn't really look at that when we were up top here. We just kind of knew that 1/2 was 2/4. But really, if you look at it, if we take 2 times 2, we get 4. 2 times 1, we get 2. Okay, so I'm going to do the same thing. We want to multiply the bottom by 3, so we need to multiply the top by 3 as well. So we're going to get 15 there. And then we're going to take this bottom number, and we need to multiply 3 by 7 to get to 21. Okay, we're multiplying that by 7. We're going to multiply that 2 by 7. Okay, so now that I have that situated, I've got 15 21sts, and I've got 14 21sts, and now I have a common denominator. Both numbers on the bottom are 21, and we're going to just set that equal to 21, and we add the top. 15 plus 14 is 29. Okay. Generally speaking, I like to see the fractions left like this. Okay, you might have had a teacher in the past who would rather see it like they'd rather see it like 1 and 8 21sts. That isn't very easy to work with if we need to take this answer and use it again somewhere else. So this just starts to look a little too complicated for me. It's great for recipes. If you need 1.5 cups of sugar, yeah, you want 1 cup and then 1/2 cup. But in math, generally, we're not through just with one answer. We want to use it again. So we're going to leave it as this what's called an improper fraction, where the top number is bigger than the bottom number, but that's okay. Okay. The next thing we're going to look at with fractions, we want to look at a situation where if I take 1/6 plus 1/6, and I add these across again. We're adding, so the denominator stays the same. 1 plus 1 is 2. So we have 2/6. Anytime we can divide numbers out of the top and out of the bottom at the same time, just like before when we multiplied numbers by the top and by the bottom, now we want to be able to divide them out because we want what's called the simplest form of this equation. Okay, so, or this expression. If you were to type in, and I'm going to have you go grab your calculator and type it in, 2 divided by 6 on your calculator, you'll get 0.3333333, and it'll keep going forever, right? As many digits as your calculator has. And then I want you to also type in 1 divided by 3, and you should get the same answer. We're looking for this answer, okay? And that just makes it easier to work with again later. All of our answers in math are because we want it to be easier. Math is not supposed to make things harder. I know that sounds odd to a lot of you, but math is supposed to make things easier. So, moving on. Now, we've looked at addition. Subtraction works very similar. So, just a quick subtraction problem. 5/7 minus 3/7. Once we get the denominators the same, That doesn't change. And we do 5 minus 3 is 2. Okay, so subtraction will work just the same way as addition. We need a common denominator, and then we can do the math. Multiplication of fractions. We like multiplication of fractions. When we're multiplying fractions, it does what we wanted it to do all along. Okay, so what we have here is, let me just say 3/5, and we're going to take 3/5 times 2/7. Why not? 3/5 times 2/7. And when we take 3/5 times 2/7, and we get 6 over 35. Now, we could look to see if we can simplify this. I happen to know we can't simplify it. 6 is 2 times 3, and 5 times 7 is 35. They don't share any common numbers, so we can't simplify it. So let's look at one that we would be able to simplify at the end. If we had 1/8 times 2/3, we came over here. 1 times 2 is 2, and 8 times 3 is 24. These are both even numbers. Any even number we can divide out of 2. 2 divided by 2 is 1. 24 divided by 2 is 12. And we have found a way to simplify that to 1/12. The last little bit we're going to look at with fractions is a division of fractions. In general, let's think of a 6. And 6 divided by 2. Okay. 6 divided by 2 we know is 3. Okay. Something that you may not intuitively think of, something that may not be quickly apparent to you, is we can turn any whole number into a fraction simply by dividing by 1. So I'm going to do that now. If I take 6 and I divide it by 1, 6 divided by 1 is still 6. If you are skeptical of that, you can try that on your calculator, but if you do 6 divided by 1, you're going to get 6. And then I'm going to divide that by 2 over 1. And we're going to look at what that equals. Whenever we are dividing by a fraction, what we want to do is flip the second fraction and multiply. You'll hear flip and multiply. The first fraction we're just going to rewrite. Okay, first fraction just gets rewritten, 6 over 1. We change this division to multiplication, and we're going to flip this fraction upside down. This is called the reciprocal of 2. So 1/2 is the reciprocal of 2. We're taking 1/2 of 6 over 1. So 6 times 1 is 6. 1 times 2 is 2. And 6 divided by 2 is 3. We just did that above. So 6 divided by 2 is 3. Using our rules for fractions, we can also arrive there. So all of that to show you, when I take 5/7 divided by 2/5, what we're going to do is we're going to take 5/7. That stays the same. Our division becomes multiplication, and then we're going to flip the 5/2. Okay, so 5/7 divided by 2/5 is the same thing as 5/7 times 5/2, and we end up with 25/14. But if you do have any questions, if anything wasn't clear in the video, please feel free to email me. My email, one more time, is linebach@mtc.edu. Or you can contact me through Canvas. That's fine as well. And just to make sure that everybody has watched all the way through this video, if you could email me the word monkey, just like the animal, monkey. I'm just curious to see how many of you actually watched the video. So I look forward to hearing from you, and at the very least, email me the word monkey. You don't have to put anything else in the email. Just say monkey, and I'll know that you paid attention. I appreciate you listening to me. That's all I got.